Hello, welcome to my YouTube video. This is Dr. Song. So I will explain today in this session how you can select the inferential statistic analysis to answer your research question. So until now, we have studied in very detailed information what descriptive statistic is and then inferential statistic is. And nowadays, we were treating after descriptive statistics about the inferential statistics. So, in fact, the very simply descriptive statistics that describe your data. So, like a data cleaning, when you receive your survey responses in your Excel data, you can import that in your SPSS software, and then you can make the kind of data cleaning using that software. So you will obtain the frequency tables of the continuous variables, and also the you can recode if you need it, if you need that, and also you will obtain a lot of information about your variables. You will use the explore function to find if there are outliers, and then what are the scores of the mean and the median and the mode, and also they are skewed or not. Your data is normally distributed or not. All these kind of things are in descriptive statistics. And then when your data is ready, you can proceed with the inferential statistics. So when you are in this stage, you will think about what kind of analysis I will have to use to answer to my research questions. So inferential statistics allows you to make predictions from that data. So you will know that if there are significant relationships, if one variable increases, the other variable also increases or decreases, etc. So you will make predictions from that data. That is about the inferential statistics. Today I will talk about that. So my course is based on those courses in the University of Alabama. So these are the references. So, in the first part, what I want to show you, when you have two variables, that is one is independent variables and then dependent variables, and then you want to mobilize those variables to make your prediction and your assumption about how is the relationship between the two. So the independent variable means that this condition affect the consequence in the dependent variable. So you can, if you have no other information like a predictor variable, the mean and mode can be your best guess in the descriptive statistics. But now you can obtain the more information by using the inferential statistics. So in that case, you need your hypothesis. So your hypothesis can be the null hypothesis and also the alternative hypothesis. So the if your result after the analysis that is a p-value is greater than 0.5, you will accept your null hypothesis. You fail to reject your null hypothesis, and then if there is a significant relationship or if there is a significant prediction, and then you can reject your null hypothesis and you accept your alternative hypothesis. So let's see some basic analysis. So there is a t-test and the regression. So these two tests, in fact, you have the dependent variable and the predictor, but only the difference is in t-test, the predictor should be the categorical variable, ordinal or nominal, and the predictor in the regression is always continuous. Or you can use also dummy variable, that is dichotomous. And the dependent variable should be always one continuous. So that is the same, like a similarity between the t-test and the regression. So in fact, the t-test means that when your predictor exists, and then how dependent variable the mean value is different. So the between the group men and the women, And then there like quantitative research method called grades. You can compare those two groups of grades, and then you can say that there is a significant difference between the two groups about their result, academic result. And then if there is a significant difference, you can reject your null hypothesis. Yes, there is a relationship between the two variables. How? Because the mean values are very different. And then if there is no significant difference, and you can say you can accept your null hypothesis, no, there is no big difference between the two groups regarding the academic grades. And then in the regression, you can say that predictor, that is like a impulsive buying, like a trend of impulsive buying, that affects your sum of the purchase. So that is your hypothesis, and then you will see how much they are close to your the regression that has a formula. So your regression line. So you will use the regression line, and you have your ANOVA test, and the significance will show that if you can predict your impulsive buying tendency, can predict how much you spend because of that reason. And then if that is possible, if that is significant, your regression line is correct, and then you can reject your null hypothesis, and then you can accept your alternative hypothesis. So that you can say that the sum of the trend of the impulsive buying that predict how much they will spend because of that reason. So that is a regression test. So in fact, this is one example. Does it help improve our guess above what is the mode and the mean of the dependent variable? Already tell us. So in fact, the mode and the mean, that is the most basic way you will predict the outcome. But the inferential statistics, like what I showed you, like a t-test or regression, that will give you the more details if that can be is significant or not. Only by the analysis you will know. You cannot know by the mode and the mean the significance, because that is too much abstract. Okay, and then now another form of the analysis is a correlation and the chi-square. The difference between the t-test and the regression, correlation chi-square, they don't have the independent and dependent variable. That means that if they are equally is affecting each other, and also chi-square also they don't have the independent and dependent variable. So the two variables, they have the relationship or not. That is about the correlation and the chi-square. Difference is correlation, they use the continuous variable, the both variables, and then chi-square, they use the both variables is a categorical. So that is the only the difference between correlation and chi-square. But both of them, they don't have the independent dependent variable. Only you want to know the relationship between the two. So that is a kind of some exercise. So you can see that. So these are the variables here. And then you can see that which analysis should you run to answer the question. Is there a relationship between the cell phone type? So cell phone type is here. That is Android, Apple. So that is a categorical variable. Social media user classification. Social media classification, yeah, that is like these are the nominal also. Non-occasional, daily, hour, non-stop. It can be like ordinary because there is some degree of the changing, but we can consider this is nominal, anyway, categorical. So categorical and the categorical, that is a chi-square. You have to choose your analysis chi-square. And then here, does hour on social media. So the hours on social media, this one, that is a continuous variable. And then that predict cell phone type. So the prediction is you can already think about the regression. However, cell phone type is only the two category. That is we consider that is a dichotomous variable. In that case, you can use the logistic regression. So that your independent variable will be continuous, and your dependent variable will be the only two groups. The dichotomous variable is a dummy variable. So it's possible you can use that in the regression. And then now another exercise here. Does cell phone type predict? Cell phone type is again the two category. Predict the hours of on social media. So the hours on social media. Okay, that is continuous. Okay, so in this case, your independent variable is your cell phone type, Android and Apple, and then your dependent variable is hours on social media. So in this case, is clearly you need a t-test because the different group is people who use Android, people who use Apple, depending on their cell phone type, their hours on social media can be different. So you can compare the means of the social media hours between the two groups. So that is definitely the t-test. And then there's gender and the cell phone. Gender is a categorical variable, and then the cell phone type is also categorical variable. Uh, cell phone type predict hours. Okay, predicts hours of the social media. So in that case, the you have the gender here, and the cell phone type. Okay, cell phone type is also here. So you have the um, two independent variables. So the gender and the cell phone type. And then you have the one dependent variable that is about the social media hours. In that case, you need the two-way ANOVA, and then that is called also factorial ANOVA because you have the two independent variables, and they are both of them, they are nominal. So that is a factorial ANOVA. And then here, is there a relationship between hours on social media and happiness? So this one is a relationship. It's not a prediction. So you will think about already is a correlation or chi-square. But the hours in the social media, that is a continuous variable. And the happiness is also the Likert scale continuous variable. So two continuous variables, the relationship between the two, you will use the correlation. And then here, does hours on social media predict stress? So hours on social media, there is a continuous variable, and the stress is also likely to scale continuous variable. So if there are both of them are continuous variable, but the predict, so that is the keyword. You can use the simple regression because there only one independent variable. So that is a simple regression. Okay. So the this is another example. So the students in the CMS 3102 perform better on the first or second midterm. So this one is a bit different questions because the one group that is a different time, first and the second midterm. So that is a group one mean, and then group one, group two mean. That is when you have the different groups. But if they have the two different times of the uh, exams, but it's only one group. In that case, you can use the t-test, but that will be the paired sample t-test. Paired because in fact it's the same people, but they have them in the different time. But if they have the different groups, and then you want to compare at the same time different groups, that will be the independent t-test. Okay, so that you should be very careful when you choose the one analysis of the t-test. When the group is different, is independent. When the group is the same, just a different time, that is a paired t-test. Okay, so this is the kind of some tricky thing. Many students they can be have the confusion. So today I explained a bit about this inferential statistics and what kind of analysis can you use depending on your research questions and also the different variable types. So next time I will continue about this part. Thank you so much for listening to my video, and then I will see you next time. Thank you.